Okay, we are back and better than ever. We're talking about the laws of probability, and the very good news is that almost all of these laws, or everything you're going to see here, are on your formula sheet. In an exercise from the previous section, we were able to see that the probability of the two events A and B, their union, is equal to the probability of the event A plus the probability of event B minus the probability of A intersect B. And that formula is right here, where the events are combined. And the probability of A intersect B is given right here, probability of A times probability of B. Now, this is just maybe an easier way to understand it, but all we really need is this formula right here. Okay, so let's just take a look at a quick example. If we have the probability of A equal to 0.6, probability of A union B equal to 0.7, and probability of A intersect B equal to 0.3, find probability of B. So this is just a plug and chug because we are given this formula right here. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersect B. And again, it's just plug and chug. So A union B is 0.7. Probability of A is 0.6. We're looking for probability of B minus probability of A intersect B, 0.3. Combine all these and solve, blah, 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 blah. We get the probability of B equal to 0.4. Just to show you how it looks visually, we'll also do this on a Venn diagram, or how you could do it on a Venn diagram. Doesn't matter either way. So I have event A and I have event B. And I know, let's see, the intersection is 0.3. And let's see, I'm going to label this A and this little a and this little b. And I know that A plus 0.3 has to equal 0.6. So I know that A equals 0.3. Okay, why do I know it's 0.6? Because the probability of A is 0.6. I also know that A plus B plus 0.3 equals 0.7 because I'm given that the probability of A union B equals 0.7. I also know that A is 0.3, so I can easily get that B is equal to 0.1, which is what I'm after, because the question is, what's the probability of B? Well, the probability of B is equal to 0.3 from the Venn diagram plus 0.1, which is equal to 0.4. So that just gives you an idea of how this formula looks visually. We also have mutually exclusive or disjoint events. If A and B are mutually exclusive, then the probability of their intersection is 0. Well, that makes perfect sense because if they are mutually exclusive or disjoint, they do not intersect, so the probability of their intersection is 0. The probability of their union is just the sum of each of their individual probabilities. And there is a formula for mutually exclusive events. It's just like we stated before. It's the same formula for combined events, but since the intersection is 0, there's no sense in writing minus 0 there. So it's just probability of A plus probability of B. Quick, very simple example to kind of think about it. Box of chocolates contains 6 with hard centers H and 12 with soft centers S. What this question doesn't say is we're going to select one of these candies. And that's what they're talking about here. Are we going to, the event is selecting one of these candies. Are H and S mutually exclusive? Well, here's how we prove it. If A and B are mutually exclusive events, then the probability of A intersect B is equal to 0. And the answer is yes, because we can't select, there's not a possibility of selecting a candy that is has both a hard center and a soft center. Probability of H, very easy, that's 6 out of 18, or 1/3. Probability of S is 12 out of 18, or 2/3. And the probability of H intersect S is 0. We just talked about that. There's no way to get them in common. And the probability of H union S, in other words, if I select a candy, will it be hard or have a hard center or a soft center? Well, 18 out of the 18 candies follow that criteria. So that's a probability of 1 or 100%. Okay, conditional probability. This is just about notation, this slash mark. There's two different ways to say it. Basically, this is A given B. Okay, that's how I always read it. And what it means is it's used to represent A occurs knowing that B has occurred. I almost always say A given that B has occurred, or A given B. And if A and B are events, then the probability of A given that B has occurred is this. And that is called conditional probability. We know something, and the formula is right there. And then the intersection, if we have a conditional probability, the intersections will change based on that and based on what's first. And we'll tackle this right here. It's just a form of this formula right here. It's just that we have A given B if it's a conditional probability. Okay, so let's take a look here. In a class of 40 students, 34 like bananas, 22 like pineapple, and 2 dislike both fruits. If a student is randomly selected, find the probability that the student blah, 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 blah. Okay, well, we're going to need a Venn diagram here to figure all this out. And we're going to solve this using a Venn diagram, and I'm going to show you how the formula works. The next example is better for these formulas. But this is just kind of showing you why the formula works. So I've got bananas and I've got pineapples. Bananas, pineapples. And all I know for sure is that 2 of the 40 students dislike all of the fruits. And to figure all these things out, I'm going to have to do the ABC thing. So I know that A plus B is going to have to be equal to 34. Those are all the people who like bananas. And I know that B plus C must be equal to 22. Those are all the people that like pineapples. And I know that A plus B plus C must equal 38. How do I know that it's equal to 38? Well, there are 40 students, and I know that 2 of them don't like either bananas or pineapples. So that leaves 38 that must be within these circles. How do I solve that? Well, looky, looky, looky. B plus C equals 22. So all of a sudden I have 22 here, and I know that A is equal to 16. Okay, so I'm just going to replace A with 16. Then everything is easy. I know that A plus B must be 34, so that means that B must be 18. And C, then, let's see, what do I know? That B plus C is 22, so this must be 4. And you can check real quick and make sure that 16, 18, and 4 and 2 add up to 40, which they do. So we're in business with the Venn diagram, and so we can go about the business of answering these questions. And first thing is the probability A that they like both fruits. Well, that's all of these guys here. So that is going to be 38 out of 40, which simplifies to 19 out of 20. Easy peasy. Okay. Oh, no, that's not, no. That's, sorry about that. Likes both fruits. Both fruits, I thought they meant any of the fruits, so sorry about that. Both fruits is the intersection, that's 18. only 18 like both of them. So that's 18 out of 40, which simplifies to 9 out of 20. Sorry about that. Likes at least one fruit. So all of these people like at least one. These 4 like only one, these 16 like only one, and these 18 like both, which falls into the category of at least one. That is the one that's 38 out of 40, which is equal to 19 out of 20. Make that a 19. Okay. All right. Likes bananas given that he or she likes pineapple. Okay. Well, I'm going to write this here. This is really the probability that they like bananas given that they like pineapples. Okay, so first I'm going to solve this using the Venn diagram. That's the simpler way. Okay, so we know that these people like pineapples. So there's 22 that like pineapples, and out of those, 18 like bananas. So the probability simplifies to 9 over 11. Well, how does that work here? Well, we're going to use this formula here, and it's a good idea to rewrite it using the new variables because there's a b here and a b in here, and you can easily get confused because it's not all that intuitive. So probability of bananas given pineapples turns into probability of b intersect p over probability of p. Just think of this first, second, second. So first was banana, second was pineapples. So that's going to be equal to probability of b intersect p. Now there's no canceling out here with these formulas, and you might want to in just a second. But b intersect p is a probability of bananas. Well, the probability of bananas, given that they like pineapple, is 18 out of 22 times probability of pineapples. Well, that's times 4 out of 22 over 4 out of 22. And I said don't cancel because I just wanted to right here because I wanted you to see that that will cancel. And we still get the 18 out of 22, which is 9 out of 11. Much easier using the Venn, but I just wanted to, for this particular problem, but I just wanted to show you how it worked out using that formula. And then finally, D, dislikes pineapple given that he or she likes bananas. So what does that look like? Well, that's really part D. You know what? I'm going to stop and finish this on the next video because it's getting kind of long. So be right back. We'll go to the next video.